What if I told you that everything you see is a lie? What if the stars aren't really twinkling points of light in the sky, but warps in a four-dimensional fabric you can't perceive? What if solid objects aren't actually solid, time doesn't actually flow, and space isn't actually empty? And what if I could show you, step by step, what the universe actually looks like when you strip away the illusions your brain creates? Stay with me, because I'm about to take you on a journey, not through space, but through reality itself. And I promise you, what you're about to discover will make you question everything you think you know about existence. Because the universe, as it truly is nothing like what you perceive. And once you see it the way I see it, you'll never look at anything the same way again. My name is Albert Einstein, and I've spent my life trying to see past the illusions, past the comfortable lies our senses tell us, past the assumptions built into human perception. Because here's the thing. Your brain didn't evolve to see truth. It evolved to help you survive, to catch prey, to avoid predators, to navigate a world of medium-sized objects moving at medium speeds. And it's very good at that. But truth was never the priority. So your brain takes shortcuts, makes assumptions, constructs a simplified model of reality that's good enough for survival, but fundamentally inaccurate. And most people never question this model, never realize they're living in a simulation created by their own neural processing. But I questioned it. I looked deeper, and what I found was shocking, beautiful, terrifying. A universe so strange, so counterintuitive, so radically different from everyday experience that even now, decades after I discovered it, most people still don't really believe it. They accept it intellectually, they learn the equations, but they don't see it, don't feel it, don't truly grasp what it means. Today I'm going to try to change that. I'm going to show you what the universe really looks like, not with mathematics, not with abstractions, but with images, analogies, descriptions that might actually let you glimpse the reality beneath the illusion. Let me start with space. You think space is nothing. Emptiness, the gaps between things, a void in which objects exist. And that's completely wrong. Space is not nothing. Space is something, a thing, a substance, a fabric. Think of it like this. Imagine the universe is an infinite sheet of rubber, stretched tight, perfectly flat. Now imagine placing a heavy ball on that sheet. What happens? The ball creates a depression, a curve, a warping of the rubber sheet. The heavier the ball, the deeper the depression. That's what mass does to space. That's what the Earth is doing right now. It's not floating in empty space, it's sitting in space, warping it, creating a curved depression around itself. And you, standing on the Earth's surface, you're not being held down by some mysterious force called gravity. You're rolling along the curve, following the geometry, like a marble circling the depression around that heavy ball. Gravity isn't a force pulling you, it's the shape of space itself. And this is literally true, not metaphorical. Space has shape, has geometry, has curvature, and mass creates that curvature. This is what I showed with general relativity. That gravity is geometry, that what you experience as a force pulling you down is actually the Earth curving space around it and you following that curve. Now here's where it gets stranger. Time is also part of this fabric. It's not separate from space, not an independent flow. Time is woven together with space into a single entity, space-time. That rubber sheet I described, it's actually four-dimensional. 3 dimensions of space and 1 of time. And mass curves all 4 dimensions, not just space, but time too. This means that time literally runs at different rates depending on where you are in the gravitational field. Right now, time is passing more slowly for your feet than for your head. The difference is tiny, imperceptible, but it's real. Your feet are slightly closer to the Earth's center, slightly deeper in the gravitational well, and time runs slower there. If you could live for billions of years, your feet would age slightly less than your head. This sounds absurd, but it's measurable. We've measured it, with atomic clocks at different altitudes, with GPS satellites that have to correct for this effect. Time is not absolute, not universal, not the same everywhere. It's local, relative, dependent on the curvature of space-time around you. So, what does the universe really look like? Not like a 3-dimensional space with time flowing uniformly through it, but like a 4-dimensional fabric, curved and warped by every bit of mass and energy, with time and space inseparably woven together, bending and stretching in response to what exists within it.
Now let me tell you about objects, solid things, tables, chairs, your own body. What are they made of? Atoms, you say. Tiny solid particles. But that's not right either. Atoms aren't solid, they're mostly empty space. Imagine an atom the size of a football stadium. The nucleus, the dense center, would be smaller than a marble sitting in the middle of the field. And the electrons? Tiny specks orbiting somewhere up in the highest seats. Everything in between? Empty, nothing. So if atoms are mostly empty and you're made of atoms, then you're mostly empty too. Mostly nothing. The feeling of solidity, the sensation when you touch a table, that's not actually your hand touching the table. It's electromagnetic forces between the electrons in your hand and the electrons in the table. They're repelling each other, creating a sensation you interpret as solid contact, but there's no actual touching, no physical contact, just forces acting across empty space. You've never actually touched anything in your life, not really. Everything you've ever felt is just electromagnetic repulsion between electron clouds, creating the illusion of solidity, of contact, of a world made of things, but there are no things, not the way you imagine them. And it gets stranger. Those electrons, those tiny particles orbiting the nucleus, they're not actually particles, not in any classical sense. They're waves, probability distributions, smeared out across space until you measure them, until you observe them. Then they collapse into a definite position. But before observation, they're everywhere at once. They're possibilities, not actualities. This is quantum mechanics, and it reveals something profound about the nature of reality. Objects don't have definite properties until they're observed, until they interact with something. Before that, they exist in a state of superposition, multiple states at once, all possibilities coexisting. And only when you look, when you measure, does reality crystallize into one definite outcome. So the universe, at the quantum level, is not made of solid things with definite properties. It's made of probability waves, potential states, possibilities waiting to become actualities. And observation, measurement, interaction, these somehow transform possibility into reality. How? No one knows, not really. This is the measurement problem, the deepest mystery in quantum mechanics. And it suggests that consciousness, or at least observation, plays a fundamental role in reality. That the universe without observers might be radically different from the universe we experience. Fuzzy, undefined, a haze of possibilities rather than a world of definite things. Let me tell you about light.
You see light as rays traveling through space, beams, straight lines from source to eye. But that's not what light is. Light is oscillating electromagnetic fields, waves in the electromagnetic fabric of space. And these waves have a strange property. They always travel at the same speed, always, no matter what. If you're standing still and measure the speed of light, you get a certain number, about 300 million meters per second. If you're moving toward the light source at half the speed of light and measure again, you'd expect the light to be moving faster relative to you, right? Like if you're driving toward another car, it approaches you faster than if you were standing still. But no, light still travels at the same speed, exactly the same. This makes no sense, but it's true. And when I tried to understand why, I realized that space and time must be relative, must adjust themselves to keep the speed of light constant. If you're moving very fast, space contracts in the direction of your motion, time slows down, and these effects exactly compensate to keep light speed the same for everyone. This is special relativity, and it means that there's no absolute space, no absolute time, only space-time. And different observers, moving at different speeds, slice through space-time differently. What you call space, I might call a mix of space and time. What you call simultaneous, I might say happened at different times. Reality itself is relative, dependent on the observer. So when you ask what the universe really looks like, you're already asking the wrong question, because looks like implies a single objective view, a God's eye perspective, from which there's one true picture of reality. But there is no such perspective. Reality is irreducibly perspectival. What the universe looks like depends on who's looking, how fast they're moving, where they are in the gravitational field. Every observer has a different but equally valid view of space-time. There's no privileged perspective, no absolute truth about what's happening now across the universe, because now is relative. What's simultaneous for you is not simultaneous for someone moving relative to you. So the universe doesn't have a single appearance. It has infinite appearances, one for each possible observer. And they're all real, all valid, all equally true. This is the revolution relativity brought, not just new equations, but a fundamental reconceptualization of what it means for something to be real. Reality is not a fixed objective thing. It's a web of relationships, of perspectives, of measurements made by different observers, and they all weave together into a consistent whole, but none of them is the absolute truth.
Now let me tell you about what space-time actually looks like on the largest scales, the shape of the universe itself. You might think the universe is infinite and flat, extending forever in all directions, but that's probably not true. We don't know the exact shape, but there are possibilities. The universe could be finite but unbounded, like the surface of a sphere. If you travel in one direction long enough, you come back to where you started, not because you hit an edge and turned around, but because space curves back on itself. In 3 dimensions, this is hard to visualize, but it's possible. Space itself forming a closed loop. Or the universe could be infinite but curved, saddle-shaped, hyperbolic, extending forever but with negative curvature that makes parallel lines diverge rather than stay parallel. Or it could be flat, Euclidean, infinite and uncurved, extending forever in the familiar way. We're still measuring, still trying to determine which of these is true. But here's what's certain. The universe is not static, not unchanging. It's expanding. And not just expanding into something. Space itself is expanding, carrying galaxies apart, like dots on the surface of a balloon that's being inflated. The dots aren't moving through the rubber itself is stretching, carrying them apart. That's what's happening to space. It's expanding, everywhere, all at once, creating more space between galaxies. And this expansion is accelerating, getting faster over time, driven by something we call dark energy, a property of space itself that causes it to expand. We don't know what dark energy is, don't understand it, but we can measure its effects, and they're undeniable. The universe is not just expanding, it's accelerating, being pushed apart by something inherent in the fabric of space itself. So what does the universe look like on the largest scale? Like a vast, expanding, possibly curved space-time continuum, filled with galaxies that are really just tiny perturbations in the fabric, little knots of concentrated energy creating curves and warps, separated by enormous voids where space is relatively flat and empty. And the whole thing is stretching, growing, accelerating, heading toward a future where galaxies are so far apart that beings in one galaxy would see no other galaxies at all, just blackness, isolation. The universe as it was before we discovered expansion, local observers thinking they're alone, unaware of the vast cosmic structure beyond their horizon. That's where we're headed, toward a lonelier universe, where future civilizations might never discover what we know now, because the evidence will have expanded beyond their reach. But I'm getting ahead of myself. Let me bring this back to something more immediate. What does your everyday world look like when you see past the illusions, when you understand the true nature of space-time? Let me describe it. You're sitting there, reading this. You think you're stationary, but you're not. You're moving at incredible speed. The Earth is rotating, carrying you at about 1,000 miles per hour if you're near the equator. The Earth is orbiting the Sun at about 67,000 miles per hour. The Sun is orbiting the galaxy at about 500,000 miles per hour. The galaxy is moving through space at about 1,000,000 miles per hour. So you're not still, you're hurtling through space-time at tremendous velocity in multiple directions at once.
And as you move, time for you is passing at a different rate than for someone at a different altitude, or someone moving at a different velocity. You're aging at a unique rate, your personal time, your proper time as we call it. And the space around you is curved, warped by the Earth's mass. You're sitting in a depression in space-time, a gravitational well, and you're not being held in place by a force, you're following the curvature, taking the straightest possible path through curved space-time. What you call sitting still is actually moving through time, traveling into the future at 1 second per second, from your perspective. But from someone else's perspective, someone moving relative to you, you're also moving through space, and your time is dilated, running slower or faster than theirs, depending on your relative motion. So the simple act of sitting still is actually incredibly complex when you see what's really happening. You're a pattern of quantum probabilities, mostly empty space, moving at tremendous velocity through multiple reference frames, following geodesics through curved spacetime, aging at a rate dependent on your position in the gravitational field and your velocity through space, existing as a four-dimensional object extended through time, not just a three-dimensional snapshot that exists only in this moment. That's what you really are. That's what's actually happening. Not the comfortable illusion of being a solid object sitting still in a stable world, but a dynamic, extended probabilistic pattern moving through curved space-time. And everyone around you, everything you see, it's the same, all of it far stranger than it appears. Let me tell you what I see when I look at the night sky. Most people see stars, points of light, static, eternal. But I see something different. I see the past. When you look at a star, you're not seeing it as it is now. You're seeing it as it was when the light left it. Light takes time to travel, so the farther away the star, the further back in time you're looking. The nearest star is about 4 light years away, so you're seeing it as it was 4 years ago. Other stars are hundreds or thousands of light years away. You're seeing centuries or millennia into the past. And distant galaxies, millions or billions of light years away. You're seeing them as they were millions or billions of years ago. Some of those galaxies might not even exist anymore, might have been destroyed or transformed, but their light is still traveling toward us, still showing us their past. So when I look at the night sky, I'm not seeing a snapshot of the universe now. I'm seeing a history, a timeline. Every point of light is a different moment in cosmic history. The sky is a time machine, showing us the past. And there is no way to see the present, no way to know what's happening now in distant galaxies, because now is relative. There is no absolute simultaneity, no cosmic present moment, just the overlapping light cones of different observers, each seeing their own slice of space-time, their own version of reality.
And here's something else that will bend your mind. When you look at yourself in a mirror, you're not seeing yourself as you are now. You're seeing yourself as you were a few nanoseconds ago, the time it took light to travel from you to the mirror and back. The delay is tiny, imperceptible, but it's real. You never see the present. You always see the past. Your brain creates the illusion of a present moment, a now. But really, you're experiencing everything on a slight delay. The light has to travel. The neural signals have to process. By the time you're conscious of anything, it's already in the past. So even your immediate experience, the world right in front of you, it's not actually happening now. It happened a fraction of a second ago. You live in the past, always, slightly behind reality. And you can never catch up, can never experience the true present, only reconstructed memories of the very recent past that your brain presents as now. This is what the universe really looks like, not a stable, solid, present-moment reality, but a probabilistic, relative, delayed, reconstructed simulation that your brain creates based on old information traveling at finite speeds through curved space-time. Most people never think about this, never realize how strange their everyday experience actually is when you look at it carefully. They live in the comfortable illusion, the simplified model. And that's fine, that's what brains are for. But I couldn't be satisfied with the illusion, had to look deeper, had to see what was really there. And what I found was more beautiful and more terrifying than I could have imagined. Let me tell you about black holes, because they show you what happens when space-time curvature becomes extreme, when gravity becomes so strong that it overwhelms everything else. A black hole is what's left when a massive star collapses, all its mass compressed into an infinitely small point, a singularity. And the space-time around this singularity is curved so extremely that there's a boundary called the event horizon, beyond which nothing can escape, not even light. If you were to fall toward the black hole, something strange would happen. From your perspective, you would fall inward at increasing speed. You'd cross the event horizon and continue falling toward the singularity. The whole journey might take seconds or minutes from your point of view, But from the perspective of someone watching from far away, from outside the black hole, they would never see you cross the event horizon. They would see you slow down more, asymptotically approaching the event horizon, but never quite reaching it. Your image would become redder and dimmer as the light from you gets stretched by the extreme curvature of space-time. Eventually, you would fade from view, but from their perspective, you would be frozen, forever approaching but never crossing. Time dilation taken to an extreme, time running so slowly near the event horizon that it effectively stops from an outside perspective.
So which view is correct? Do you fall in or don't you? The answer is both. Both are correct. Both are real. Because reality is perspectival. There's no absolute truth about what happens, only different, equally valid perspectives. From your perspective, you fall in, experience the singularity, end. From the outside perspective, you never quite cross. You're frozen at the boundary, forever. Both are true, simultaneously. This is what general relativity teaches, that reality at extremes becomes irreducibly relative, dependent on the observer. And inside the black hole, past the event horizon, space and time switch roles. The direction toward the singularity becomes time-like, inevitable. You can no more avoid hitting the singularity than you can avoid moving forward in time right now. And the direction away from the singularity becomes space-like, impossible to reach. Just as you can't move backward in time, you can't move away from the singularity once you're inside. This is what space-time looks like at its most extreme, curved so much that the basic categories of space and time break down, exchange roles, create inevitabilities and impossibilities that don't exist in normal space-time. And at the very center, at the singularity, our equations break down completely, stop working, give infinite answers, tell us that space-time itself ends or transforms into something we can't describe, something beyond our current physics. This is where general relativity fails, where we need a theory of quantum gravity to understand what really happens. But we don't have that theory yet. So the center of a black hole remains a mystery, a place where space-time itself might end or might transform into something completely different. We don't know, can't know with our current understanding.
Let me tell you about what I find most beautiful about the universe when you see it truly. The unity, the simplicity underlying apparent complexity. When you look at the world with everyday perception, everything seems separate, disconnected. Space is one thing, time is another, matter is something else, energy something else again, forces, objects, all different, all distinct. But when you look deeper, when you see what the universe really is, you find that it's all one thing. Space-time is a single fabric. Matter and energy are equivalent, convertible into each other. E equals mc squared. Energy is mass times the speed of light squared. They're not different things, they're the same thing in different forms. And forces, they're not separate entities acting on matter. They're manifestations of the geometry of space-time. Gravity is curvature. Electromagnetism is oscillations in fields. The strong and weak nuclear forces are symmetries in field interactions. Everything unified, everything connected, everything aspects of a single underlying reality. And this reality is mathematical, not in a superficial way, not just describable by mathematics, but actually mathematical in its essence. The universe doesn't just follow mathematical laws, it is mathematical structure.
The equations aren't descriptions of reality, they are reality. Or at least they're as close as we can get to reality, as close as our limited human minds can comprehend what's truly there. This is what I found most moving, most profound, that beneath the chaos and complexity and diversity of the world, there's simplicity, unity, order, a single, elegant structure underlying everything. And we can understand it. We can discover these patterns, can write down equations that capture something true about the fundamental nature of existence. Not perfectly, not completely. Our theories are always approximations, always limited, but they work, they predict, they explain, they reveal structure that's really there, and that's miraculous. That the universe is comprehensible, that it follows rules, that we, products of the universe, can understand the universe that produced us. There's no obvious reason this should be possible. The universe could have been chaotic, lawless, incomprehensible, but it's not. It's ordered, law-governed, understandable, and that suggests something profound about the nature of reality itself. Something I never fully understood, but always felt, that consciousness and cosmos are somehow connected, that the universe is not just a dead mechanical system, but something more, something that includes awareness, understanding, beauty, purpose perhaps, though I'm not sure about that last one, but something more than just particles moving through space-time according to equations, though I don't know what that something is. This is what I see when I look at the universe, not with my eyes, but with my mind, with equations, with imagination, with the ability to visualize what can't be directly perceived. I see a four-dimensional space-time fabric, curved by mass and energy, with time and space inseparably woven together. I see quantum probabilities collapsing into actualities through observation. I see matter and energy as equivalent, interconvertible, different manifestations of the same underlying reality. I see forces as geometry, as the shape and dynamics of space-time itself. I see light as the absolute speed limit, the cosmic speed limit that everything else is measured against. I see myself as a four-dimensional pattern extended through time, not a thing that exists only now, but a world line through space-time, a trajectory from birth to death that exists as a complete object in the four-dimensional structure.
And I see the illusion, the comfortable lies that human perception tells, the model your brain constructs that makes reality seem stable, solid, simple, present, when really it's dynamic, probabilistic, complex, and always in the past. This is what the universe really looks like, not comfortable, not intuitive, not easy to grasp, but true, or at least truer than the everyday illusion, closer to what's actually there. And once you see it, once you really understand it, you can't unsee it. The world is forever transformed, forever strange, forever more interesting and more mysterious than it appeared before. That's what relativity gave me. Not just equations, not just predictions, but a new way of seeing, a vision of reality that's radically different from everyday experience and more beautiful for being true, more profound for being real. This is the gift I want to give you, not the mathematics, not the technical details, but the vision, the ability to look at the world and see past the surface, see the four-dimensional fabric underneath, see the curvature, the relativity, the quantum uncertainty, the deep connections between things that seem separate. to see the universe as it truly is, strange, beautiful, unified, and fundamentally different from what you perceive with your everyday senses. That's what the universe really looks like, according to Einstein. Not a place, but a process. Not objects in space, but patterns in space-time. Not separate things, but aspects of a connected whole. Not solid and fixed, but dynamic and probabilistic. Not simple, but elegant in its complexity. Not intuitive, but comprehensible to those willing to look carefully, to think deeply, to set aside comfortable assumptions and face the strangeness of what's actually there. That's reality. That's the universe, and it's more magnificent than any human imagination could have invented, because it's real, because it's there, because this is what existence actually is, and we get to witness it, understand it, be part of it. And that's the greatest privilege of conscious existence, to see, to know, to comprehend, even if only imperfectly, even if only approximately, even if always from a limited perspective. We see something true, something real, something magnificent, and that's enough. That's everything. Hit subscribe to keep exploring the true nature of reality.